Hello students, in the last lecture we discussed series and parallel connection of spring. Okay, in series connection, if you want to find equivalent spring constant, then reciprocal addition, and in a parallel connection, direct addition. So now we discuss one concept, that is for reduced mass. Reduced mass. So what is the meaning by reduced mass, students, that we want to discuss? Reduced mass. Suppose there are the two block M1 and M2, and between two block one spring is connected. Between two block one spring is connected. Between two block one spring is connected. So students, see now what is the mass, what is the effective mass. Suppose if only one spring, if with the spring only one mass is there, then in the case of time period we consider its total mass m. But here two mass as the between two mass one spring is connected. So now we consider its reduced mass. And what is the formula for reduced mass? Reduced mass is equal to mu is equals to m1 m2 upon m1 plus m2. Reduced mass is equals to what? m1 m2 upon m1 plus m2. So now what is the formula of time period? See, time period is what? M by k, but here we consider reduced mass mu. So here we write mu by k, not m by k but mu by k. Okay, mu is a reduced mass. When we consider reduced mass, when between two block one spring is connected, then we consider reduced mass. Sure. Now students, see one question based on the reduced mass. Two block 1 kg and 3 kg. Two blocks are there, 1 kg, 3 kg. It is a spring constant K. What is the value of spring constant? 300 Newton per meter. Okay, and we want to find frequency, students. We want to find frequency of oscillation, frequency for SHM, or simple harmonic motion. So again, see students, here between two block one spring is connected, so we consider its reduced mass. Okay, so we consider it what? Reduced mass. So now how to consider its reduced mass? See, so what is the kinetic energy? 300 Newton per meter, and we want to find its frequency. So first consider reduced mass. Why we consider reduced mass? Because between two block one spring is connected. So m1 m2 upon m1 plus m2. So 1 into 3 upon 1 plus 3. So what is the reduced mass? 3 by 4 kg. What is the reduced mass? 3 by 4 kg. Chalo, now what is the time period? T is equals to 2 pi T is equals to 2 pi under root mu by k. So 2 pi, it is time period, students, but we want to find frequency. So frequency is a reciprocal of time period. So on reciprocal, so it become k by mu. Okay, we take reciprocal. Chalo, so 1 pi is 3.14, k 300. What is mu? 3 by 4. 300 by 300, then 4 is also in multiply, so it becomes root of 400. And what is root of 400? 20. So 10 by 3.14, so it is approx what? 3 hertz. Okay, so this is the concept of reduced mass. Chalo, now next question. A body of mass a body of mass 4.9 kg, a body of mass 4.9 kg a body of mass 4.9 kg hangs from a spring. Body of mass 9.5 kg hangs from a spring and oscillate with a time period of 0.5 second. So we can write that. What is its time period? 1 by 2 second. Now when body is removed, from equilibrium position, then when body is removed from equilibrium position, then find compression in spring. Then find compression in spring. Okay, and the options are G is equals to 10 meter per second square and pi square equal to 10. Okay, G is equals to what? 10 meter per second square and pi square equal to 10. When body is removed from the equilibrium position, then find compression in spring. So we want to find compression in a spring. So see students, now see when a spring is connected, okay, suppose you think suppose તમે spring સાથે block connect કરો તો spring stretch થઈ જશે students. Why? Because due to the weight of spring mg. But when body is removed, suppose તમે આ body ને attach કરો છો, but when body is removed, then restoring force is acting on a spring, and again spring is compressed. So that restoring force is act on a spring is what? Is same as weight of body. પહેલા mg જેટલું ડાઉનવર્ડમાં લાગે, but when we remove the body, then mg જેટલું અપવર્ડમાં લાગે. Okay, so now see when body is removed F is a restoring force. So we can say that when body is removed, restoring force of spring is equals to what? Weight of body. Chalo, so what is the restoring force? Kx. What is the weight? mg. We want to find compression in a spring, so mg by k. But what is the problem, students? Spring constant is not given here in our question. Spring constant is not given. Okay, so first we want to find spring constant. Okay, અહીંયા spring constant નથી, but see time period is given. So from the formula of time period, find spring constant. So T is equals to 2 pi under root m by k. Now square on both the side. So 4 pi square m by k, take k as a subject. So 4 pi square m by t square. Okay, what is k? 4 pi square m by t square. Cancel. So what is x? T square is in multiply. So what is x? G t square upon 4 pi square. G t square upon 4 pi square. Chalo, what is G? 10. What is time period? 1 by 2, 4. What is pi? 10. So 1 by 4 into 1 by 4. 1 by 4 into 1 by 4. 1 by 4 means 0.25. 1 by 4 means again 0.25 into 0.25. So it is 25 into 25, 625. So it is 625 into 10 raised to minus 4 meter. So we can write that 6.25 into 10 raised to minus 2 meter. So 6.25 centimeter. Okay, so what is the compression in a spring? 6.25 centimeter. Chalo, so now next question. So now see students, between two fixed and two spring of spring constant K are connected in parallel. Okay, there is an inclined plane. On inclined plane between two fixed and two springs are connected in parallel. How to know these springs are in parallel connection? Because between two spring one block is there, so it is a parallel connection. Now we want to find time period. And the options are 2 pi, Option C 2 pi. mg sin theta 2 pi mg sin theta upon 2k raised to half. Option D 2 pi Chalo, okay. So students, here we want to find time period. Okay, chalo. So see students, oscillation in a spring is due to its restoring force. For in the case of oscillation of spring, which force is the necessary restoring force? And students, in the case of restoring force, there is no effect of gravity. Restoring force does not depend on gravitational acceleration. Okay, so restoring force in the spring okay, for oscillation of spring, restoring force in a spring is responsible. Which force is responsible, students? Restoring force in a spring is responsible. Okay, due to the restoring force in a spring, spring can oscillate. Okay, it does not depend on a gravity. Okay, so oscillation of spring oscillation of spring does not depend on gravity. Okay, બાકી તો આપણે શું થાય સ્ટુડન્ટ્સ, તમને યાદ હશે કે in the case of laws of motion, when object is placed on inclined plane, then we draw x axis and y axis, then mg is downward, here theta. So here we consider mg cos, here we consider mg. So then we take mg sin theta is a required force, students, for the moving of block. But here for the oscillation, which force is required? F is equal to minus ks, and it does restoring force is required, and it does not depend on a gravity. So students, here we cannot consider force equal to mg sin theta. Okay, so તમારે શું લઈ લેવાનું ખાલી આમાં general formula T is equals to 2 pi m by k dash, where k dash is the equivalent spring constant. And what is the equivalent spring constant? Both springs are in parallel connection. So both springs are in parallel connection. So what is the equivalent spring constant? K plus k. So what is the equivalent spring constant? 2k. So what is our answer? 2 pi m by 2k. Okay, so what is our answer for equivalent spring constant? 2k, because direct addition. So what is the answer? T is equal to 2 pi m by 2k. Sure. Now next question, students. Suppose here two springs are there, both the springs are connected in series. Now we want to find what frequency of oscillation in the two case. Okay, we want to find frequency of oscillation in the both the cases. Okay, we want to find nu1 by nu2 for both. So how to find, students? See students, in the first case, these both the springs are in series connection. That is what? Series connection. So in series connection, what is the effective spring constant? 1 by k plus 1 by k. So what is the value of k1? K by 2. Okay. Then here what is the spring constant? These two are in parallel connection. So what is the answer of them? 2k. Then this k and 2k again are in series connection. Okay, agar block kya hoy end upar hoy, then it is series connection. So again k and 2k are in series connection. So again reciprocal addition, 1 by 2k plus 1 by k, 1 by 2k plus 1 by k. So now take LCM. So 2k is a LCM. So 1 plus 2. So what is k2? 2k by 3. So now we want to find ratio of frequency. So what is the time period for SHM? T is equals to 2 by m by k. So what is the frequency? It reciprocal. So see students, in the both the case mass of block is same, that is m. So now we can say that this frequency is directly proportional to root k. This frequency is directly proportional to root k. Okay, so nu1 by nu2 is equal to k1. 2 pi is constant. So what is k1? K by 2, and here 2k by 3. So 3 is in denominator, 2 into 2 4. So what is the answer? Root 3 by 2. Okay, so what is the answer? Root 3 by 2. So now next students, we discuss total energy for SHO. So now next we discuss total energy of SHO. Total energy of SHO means total energy for simple harmonic oscillator. Okay, so we derive that equation. So total energy of SHO means what? Total energy means kinetic plus potential. So first we find potential energy. So what is the potential energy of spring? So potential energy of spring is equals to what? Half kx square. Potential energy of spring is equals to what? Half kx square. What is the kinetic energy? So kinetic energy is equals to what? Half mv square. And what is the formula of speed, students, for SHM? For simple harmonic motion, what is the formula of speed? V plus or minus omega under root a square minus a square. What is the formula of speed? V under root a square minus a square. Chalo, so what is the kinetic energy? Half plus or minus omega a square minus a square. So half m omega square a square minus a square. चलो further अगर simplify करिए student, then what is omega under root k by m? So what is omega square k by m? So 1 by 2 m omega square is k by m. Cancel. So what is kinetic energy? Half k a square minus a square. What is potential energy? Half k a square. What is kinetic energy? Half k a square minus a square. चलो, सो स्टूडेंट्स आ भी याद रखो, पोटेंशियल एनर्जी ऑफ स्प्रिंग तो तमने याद ज हशे, हाफ के स्क्वेर, અને આ બી યાદ રાખવાનું છે, કાઇનેટિક એનર્જી ઇઝ ઇક્વલ ટુ હાફ કે a square minus a square. Now what is the total energy? If you want to find total, then add them. Total energy is equal to kinetic plus potential. What is kinetic? Half k x square minus a square. What is potential? Half k x square. What is potential? Half k a square. Chalo, so now half k common, half k common, so a square minus x square plus a square cancel. So what is the total energy? Half k a square. What is the total energy? Half k a square. Potential energy half k a square. Kinetic energy half k in bracket a square minus x square. What is the total? Half k a square. Chalo, done. Now next question. See the question. આ યાદ રાખજો સ્ટુડન્ટ્સ, ટોટલ તો યાદ રાખવાની છે, અને also remember kinetic and potential energy, right? So now see students, with the spring, with the spring of spring constant K, mass 4 kilogram block is attached, and spring constant of spring is 800 newtons per meter, and it perform SHM. As we know, spring perform simple harmonic motion. total energy of spring is 4 joule. We want to find maximum acceleration. Okay, we want to find maximum acceleration of spring, means simple harmonic oscillator. Spring is a simple harmonic oscillator. So, and the options are 5 meter per second square, option B 15 meter per second square, 45 meter per second square, and 20 meter per second square. Chalo, so with the block, with the spring 4 kilogram block is connected, spring constant is 800 Newton per meter, and it perform SHM. What is its total energy? 4 joule, and we want to find maximum acceleration of SHO. So students, first, what is the formula for maximum acceleration? Chalo, so in case of SHM, maximum acceleration is, what is the maximum acceleration? Omega square A. Okay, but omega is not given, so what is the omega for SHM? Omega is K by M, so omega square is K by M. So here we write K by M. So now students, we know the value of K, we know the value of M. So now find amplitude. Okay, now we want to find, because amplitude is not given, students. See, we need amplitude. What is the formula of acceleration? Minus omega square x. But for maximum acceleration, what is the formula? Omega square A. Okay, so A is not again, A is missing, students. So how to find A? See, total energy is given. So total energy is equal to half Ka square. So 4 joule. What is K? 800. So 8 by 800 means 1 by 100. So what is the amplitude? 1 by 10 centimeters. Sorry, all are in meter. So what is the amplitude? 1 by 10 meter. Now placed here. What is K? 800. What is mass? 4. What is amplitude? What is amplitude? 1 by 10. So 80 by 4. So what is the maximum acceleration? 20 meter per second square. Okay, what is the maximum acceleration? 20 meter per second square. Chalo, now next question. Chalo, now next question, starting from origin. Starting from origin, or we can say that, students, mean position. Starting from origin means mean position. Starting from origin means mean position. Body perform which motion? SHM. Okay, starting from origin, body perform SHM. And what is the time period? Time period means time required to complete one oscillation. What is the time period? 2 seconds. Okay, now we want to find time. Now we want to find time when kinetic energy of oscillator become 75% of total energy. Kinetic energy of oscillator becomes 75% of total energy. Chalo, and the options are 1/12 second, 1/4 second, 1/6 second. Option D, 1/4 second. 1/3 second. Option D. So see students, starting from origin. Okay, so it start the oscillation from origin means this type of graph. This oscillation start from mean position. Now kinetic energy is what? 75% of total energy. Kinetic energy is 75% of total energy. When kinetic energy is become 75% of total energy, find time. Okay, so what is the formula of kinetic energy? Half K A square minus X square, replacing percentage, so divide by 100. So 75/100. What is total energy? Half Ka square. Right? See, આપણે derive કર્યું. See, we derive the kinetic energy. What is the kinetic energy? Half Ka square minus X square. What is the total energy? Half Ka square. Chalo. Okay. So K cancel. This half cancel, so 75/100 means 3/4, so A square minus 3/4 A square is equal to X square. Now take LCM, so 4A square minus 3A square, so A square by 4. Now take root. So what is X? X equals to A by 2. What is X? X equal to A by 2. So we get the X, students, and what is the X? A by 2. Chalo, now but we want to find time, students. Okay, so now consider the equation of X. What is the equation of X now? X equals to A sin omega t. Why we consider sin? Because oscillations start from origin, from mean position. So that's why we take sin. Our graph kono hoy? Sin. If oscillations start from extreme position, then we take x equal to cos, because cos start from upward. Okay. But here oscillations start from mean position, so we take x equals to A sin omega t. Chalo, so now what is X? A by 2. A cancel, so 1/2 equal to sin omega t. So sin omega t is 1/2 when angle becomes pi by 6, sin 30, sin pi by 6, 1/2. Now we want to find time, and time period is given, so 2 pi by t. Pi cancel, so what is the time? T by 12. And what is the time period? 2 seconds, so 2/12. So what is the time? 1/6 second. Okay, so what is the correct answer? See, 1/6 second. What is the time? 1/6 second. Chalo, next question. Next question. A particle start SHM from mean position. Particles start SHM from mean position. What is the time period? What is the time period? T. Chalo, we want to find ratio of kinetic energy by potential energy. For SHM, find ratio of kinetic energy and potential energy when time is what? T by 12. Capital T is time period. Okay, find ratio of kinetic energy and potential energy when time is T by 12. And the options are 1/2, 2, 3 and 4. Sure. Done, students. The particles start SHM from mean position. What is the time period? T. We want to find ratio of kinetic and potential energy when time period is T. So again, see students, here particle start SHM from mean position. Okay, particles start SHM from mean position. So again here we take what? X equal to A sin omega t, right? Sure. Now we want to find ratio of kinetic and potential energy. So kinetic energy by potential energy. Kinetic energy half k x square minus a square. Potential energy potential energy is half k x square. So k cancel, half cancel. So what is the answer? X square minus s square by x square. What is the answer? A square minus x square by a square. Chalo. So students, now again see, again here we want to obtain relation between x and a. So again use what? X equals to now a sin omega t so what is omega? 2 pi by t. What is time? Say time is t by 12. So t cancel. So a sin pi by 6 and sin pi by 6 1/2. So what is x here? A by 2. Okay, so place the value of x now. Okay, place the value. So x equal to a by 2, but it's square. So a square by 4. A square by 4, take LCM. So 4a square minus a square means 3a square by 4 upon a square by 4. A square cancel, 4 cancel. What is the answer, students? What is the ratio? 3. Okay, so that is the final answer. What is the final answer? 3. Chalo, now next question, students. Chalo, now next question. For SHM, potential energy U is given by 20 plus x minus 2 whole square. Okay, for SHM, potential energy is given by 20 plus x minus 2 whole square. If total energy is 36 joule, if total energy is 36 joule, find maximum kinetic energy. Okay, if total energy is 36 joule, find maximum kinetic energy. So see, students, if kinetic energy is maximum, then potential energy is minimum, because if kinetic energy is maximum, then potential energy is of course minimum. So now students, the equation of potential energy is given. What is that equation? 20 plus x minus 2 whole square. Now students, remember one thing, कोई भी quantity maximum के minimum होय, then its differentiation is always 0. If any quantity is maximum or minimum, then its differentiation is 0. So here kinetic energy is maximum, so its differentiation is 0. Here potential energy is minimum, so again its differentiation is 0. But આપણે અહીંયા equation કોની છે students? Potential energy નું. તો આપણે કોનું differentiation કરશું? We can take differentiation of potential energy. So potential energy is minimum. Why we take potential energy minimum? Because we want to find maximum kinetic energy. So it means differentiation of potential energy is 0. Potential energy is in the terms of x, so differentiation is with respect to x. Okay, why we take differentiation of potential energy is 0? Because potential energy is minimum. कोई भी quantity minimum के maximum होय, तेनुं differentiation 0 લ્યો. So what is the potential energy now? Potential energy is 20 plus x minus 2 whole square. What is the total energy? What is the potential energy? 20 plus x minus 2 whole square. Now differentiation of 20 is 0. Now multiply with the, what is the formula of differentiation? Multiply with the power and 1 minus from the power. Students, see, there is no coefficient of x. अगर x नो कोई coefficient होत तो આપણે multiply करવું પડે. Okay, but here coefficient of x is 1. If another, suppose 3x minus 2 whole square, then we multiply by 3 because coefficient of x is 3. So 2. So we can write x minus 2 equal to 0. Okay, so now we can say that, so at x equals to 2, potential energy is minimum. So at x equals to 2, potential energy is minimum. Chalo, so what is the minimum potential energy? So what is the minimum potential energy? What is the formula? 20 plus x minus 2. When we placed here x equal to 2, then potential energy is minimum. So at x equals to 2, potential energy is minimum. So 20 plus 2 minus 2 whole square, x equal to 2. 2 minus 2, 0. So what is the minimum potential energy? 20 joule. Now we want to find maximum kinetic energy. So E is equals to E is equal to K plus U, kinetic maximum, potential minimum. Chalo, what is maximum kinetic energy? 36. What is the minimum potential? 20. So what is the maximum kinetic energy? 36 minus 20. So 16 joule. Okay, so what is the maximum kinetic energy? 16 joule. Okay students, now next we want to find average value of kinetic and potential energy. Okay, now we want to find average value of kinetic energy and potential energy for SHM. Chalo, so students, first, as we know, in a derivation we take x equal to a sin omega t. So what is the velocity, students? Velocity is equal to dx by dt. What is x? A sin omega t, a constant. Differentiation of sine is what? Cos omega t into omega, multiply with the coefficient of t. So what is the velocity? What is the velocity? Omega a cos omega t. Chalo, now what is the potential energy, students? What is the potential energy? Half k x square. And what is x? A sin omega t. So what is the potential energy? Half k a square sin square omega t. Okay, so now we want to find average value. So what is the average value? This is the symbol of average. This is the symbol of average, bracket. Half k a square constant Chalo, half k a square is what? E. Half k a square is what? E. Chalo, this is E, half k a square E. And what is the average value of sine, students? Average value of sine is 0. Average value of cos is 0. Average value of sin square omega t 1 by 2. Average value of cos square omega t is also 1 by 2. તમે ભણ્યા છો alternating current. So what is the average value of sin square omega t? 1 by 2. So what is the average value of potential energy? Half of total energy. Okay, chalo, so same now for kinetic energy. For kinetic energy, half mv square. What is v? Omega a cos omega t, but it's square, So omega square a square. Now what is omega? Omega is root k by m and its square, so k by m. So here we write half m, omega square means k by m, cancel. So what is the kinetic energy? Half k a square cos square omega t. So now the take average. This is the bracket is a symbol of average. Okay, this is the average. This is known as average kinetic energy. So half k a square cos square omega t. Half k a square is known as E. And what is the average value of cos square? Again 1 by 2. So same answer, students. So always remember average value of potential energy and kinetic energy is what? Half of total energy for SHM. For SHM, average value of potential energy and kinetic energy is half of total energy. Now again students, if we add, if you want to find total energy, તમારે આમાંથી find કરવી હોય total energy તો બી થઈ જાય. Add them. Total means potential and kinetic. So half k a square common, sin square omega t plus cos square omega t, that becomes 1. So again we obtain half k a square.